Hello, hello, hello. Number 6. There are 45 teachers, 31 are women, 14 are men. How many different committees are possible with 2 men and 2 women? So this one we'll recognize to be a combination. Always committees are combinations because the order doesn't really matter. So if I'm on the committee and you're on the committee, it's the same as if you were on the committee and I'm on the committee. So the arrangement doesn't matter. So we're going to do combination. And the first combination I'm going to set up is for the women. There were 31. That's a 31 combination of taking 2 at a time. That's for the women. And then I'm doing the men, times the combination of 14 men taking 2 at a time. So getting a combination for first the women and then the men, I multiply those numbers. And these are the numbers that's the number of possible committees. All right, number 7. How many different arrangements can be made with the letters in the word Maryland? Because we have some letters that are repeated, just the A's, we have to account for that. So we start with, we learned that the number of distinguishable permutations is n factorial, which is 1, 2, 3, 4, 5, 6, 7, 8 factorial, divided by the number of repeats. So in this word we only have 2 A's that are repeated, so we'll divide by 2 factorial. So we get 8 factorial divided by 2 factorial comes up 6,720. All right, number 8. 5 cards are dealt. What is the probability? They are the same suit. So on that one, we set up 5 blanks, and how many ways can we fill the first blank? Well, there's no real restrictions until we find out what suit we have, so I put a 52 in the first blank. But once I do that, it totally restricts the number in the second blank, because if I picked, for example, a heart, how many other hearts would be in the deck for me to choose from? Well, there's 13 of each suit, so obviously I've picked 1, so then there's only 12, then 11, and then 10, then 9. So that's the probability then will be set by dividing by all possible ways to fill in your hands with no restrictions. And when you divide this product by this product, I got 0.00198. All right. How many signs with 4 letters followed by 4 digits with no repeats? All right, and then we're going to do it with repeats. So we're going to have 4 blanks and 4 blanks, so 8 blanks. The first one will be with no repeats, so how many different letters could we fill the first blank with? 26, then 25, 24, 23. And followed by numbers, they're 10 digits, 10, 9, 8, 7 with no repeats. So here's that answer. 26, 25, 24, 23, 10, 9, 8, 7. How will those change if we are going to follow that with repeats being allowed? This will be 26, but what will this be? Also 26, and then all the digits 10, 10, 10, 10, allowing repeats. The numbers look like that, and we get quite a large number there. What's that? 4,569,760,000. All right, lastly, there are 2 red marbles, 5 white marbles, and 7 blue marbles. One is drawn and returned. Another is drawn. What's the probability of drawing a red and then a blue? All right, since we are putting them back, it's with replacement. we see that the probability of the two events, the probability of red then blue, is the probability of red times the probability of drawing a blue. So the probability of drawing a red is 3 out of 15, and then the probability of drawing a blue is 7 out of 15. We multiply those two probabilities to get the final answer, 21 out of 225, reducing to 7 out of 75. All right, these 10 problems and the last review sheet, which also had 10 problems, should be a main source of study, as well as just look through your comp book and your homeworks at all the different kinds of probability problems and counting problems that we have studied. All right, study hard and do me proud. Carry on.